Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we're going to be talking about aliasing and mutability. And these concepts are actually closely related to aspects of things we've been talking about recently with arrays and lists and functions. But I kind of want to bring things together and give you a picture of kind of what's going on inside of the computer, what you can picture in your head as your mental model for what's going on with certain things. So first we want to talk about this concept called aliasing. Inside of Scala, we can declare a variable. Let's say we're going to declare a val. We'll call it a, actually let's make it a var just because that will be good for a demonstration. Var a equals 5. Okay. Now, what should you picture inside of your head when you see that line of code? I would argue that an appropriate picture for this is something like the following. So when we declare this var a, we're getting a box, okay? And this box has a name to it. The name is a, and this box doesn't actually store the value of 5. What it does is it stores a reference to an object that has that value 5. This is really kind of the mental image that goes along with the Scala way of doing things. So we can represent the 5 as an object over here as a little box with the value 5 inside of it. More complex objects might have more inside of them, but this is a fairly simple object here. And when we say that a equals 5, we're doing that. We are drawing a connection from a and making it reference the object 5. The difference between a val and a var is that in a val, you can't move this arrow, and in a var, you can. So for example, if I were to now say a equals 7, what that's doing is it's not changing the value in this box over here. Instead, it's making a new box which has the value 7 in it, and because a is a var, it can change the arrow. If you declare something as a val, you can't move the arrow. So the difference between val and var is whether or not you're allowed to move the arrow that is pointing out of the reference, the variable that you've created. Okay, that's the only difference. It has nothing to do with the contents of these boxes over here. Val versus var is whether or not you can move the arrow. We've also talked about this concept of mutability, and we've said that one of the big distinctions between arrays and lists is that arrays are mutable and lists aren't. Now, what exactly does that mean? So let's come back over here and let's make an array, and let's just give it some simple integer values. 3, 8, 2, 5, 9. So I have this array here. And we can also make a list that has the same numbers. The difference between being mutable and immutable is that the array object, the values that it stores inside of it can be changed. So I can say arr sub 3 equals 1. And after doing that, arr has been changed. And we can set it back to 5. I can't do the same thing to the list. Okay. I get an error with that. It says that you're not allowed to update elements in a list. In fact, it's not just doing the assignment. There is no method that you can call on a list which actually alters the list. Everything that you do on a list is going to leave the original the same. It might create other lists for you that are different in some way, but the original is never altered. Whereas with the array, the original is altered. So to see what this looks like, instead of having our a here, let's imagine this is ARR. Okay. And when I created that array in the first place, what I am doing is I am making an object over here, an array of ints that has the 3, 8, 2, 5, 9. And then I am saying that I want to connect this to that. So that is what this line right here said. And because this is a val, I'm not allowed to change this arrow. Okay. Now technically, because I am inside of the RAPL, I could create a new box called ARR and make it point to something else. But this ARR is always going to have an arrow that points to this box over here. That's what it means to be a val. But because the array is mutable, I was able to do this line. And what that does is it reaches in here and it takes this one element and it changes its value. Okay. If it were a list, I couldn't do that. Okay. The stuff over here inside of this box would be fixed forever once it was created. But the array is mutable. So that's the basic idea of mutability, is that the box over here you can change. In the case of 5, an int, ints are not mutable. In fact, of all the different types we've talked about, the only one so far that is mutable is arrays. Ints, doubles, strings, lists, tuples, all of those are immutable. They do not have, all of the methods on them leave them unchanged. Okay, and so arrays are our only example so far of something that is mutable. Now, this is significant in many ways, one of which, and one of the things that you kind of need to understand when you're programming, is the impact that this can have on your programs when we invoke the option of aliasing. Now, what does it mean to have an alias? Well, in the case of humans, we say that someone has an alias if they go by an alternate name. And basically, that's exactly what we mean in programming as well. I can do something like this. Okay. This line here says I'm creating a new variable. It's named b. Okay. And b is going to reference, it's going to point to the same thing that ARR points to. So when I execute that line of code, you can see we have our array here. What happens in our picture? Well, the picture does the following. We get our new b, and this b gets a reference to there. Okay. So now ARR and B both point to the same object. They are aliases of this single array. And this can be very significant in your programming because of lines like the following. Okay. It said B sub 0 equals 7. What does that actually mean? Well, if we come up here, what that does, it says, okay, I'm going to follow B, and I'm going to take the sub-0 element, which is this first element, and I'm going to change it to 7. Yeah. That's all fine. And so you can look at B and see, indeed, the first element has been changed to 7. But what you can see from the picture up here is I didn't just change the value of B. Because B was an alias for ARR, I changed the value of ARR as well, or at least I changed the value of what ARR references. And that's fine if that's what you meant to do, but it's a big problem if it's not what you meant to do. Okay, so this is something that you have to be aware of, is that when you create aliases, you have, if an object is mutable, it can be altered through the aliases. And it turns out that can create very hard to find and fix. They can create errors, bugs that are very hard to find and to fix. Now, of course, you might say to yourself, well, I would never make a line like this. Okay? I would never just create a second name for the same array. And maybe that's true. Actually, it turns out there are places where you will wind up doing that. But there are places where you wind up doing this even though it isn't really, you might not realize that you're doing it. And to see an example of this, let's deal with calling functions. So I'm going to start with our simple, fun factorial function. And so if n is less than 2, we give back 1, else we give back n times the factorial of n minus 1. Let's make a variable that is an int. Well, we have one here. We have a. Okay, so let's